Today we're going to discuss about the distance formula in a two-dimensional coordinate system. So for example, these are your points. This will be called my point 1 and this will be called my point 2. Now since this is called point 1, my x is x sub 1 and my y is y sub 1. Same is true with this one, which is x sub 2, y sub 2. Before we go into the derivation of the formula of the distance in a two-dimensional coordinate system, I would like to focus you on the Pythagorean theorem being the basis of the distance formula. So if this is your triangle, I'm going to call this my C because that's the side opposite the right angle and that's your hypotenuse, and I'm going to call this my, I can call this my A, I can call this my B. Either way, these are the legs, and so it can be any of the two. So the distance formula for the hypotenuse or the length of the hypotenuse is A squared plus B squared equals C squared. And we know that to remove this squared, it's going to become 8. So you get the radical of those both sides. So the C, or the length of this, is the square root of A squared plus B squared. This is going to be our basis in getting the distance between P1 and P2, which I'm going to call this as my D. And now let us begin. So because this is x1, y1, I assume that this is your x1 right here. And since this is x2, I'm going to call this my x2. Okay. So now, let's look at this point. This point has, for this y, that's going to be my y2. And this is going to be my y1. Okay. Now, we know that to get the, so let's make a right triangle here. And we know that to get the distance of a length, we have to subtract this point with this point. So, but wait, let's derive this point. This point, I suppose, is x2, y1. And all I did was to look at this point and see the x-coordinate and the y-coordinate. And so, this right here, which is equivalent to our A, is actually y2 minus y1. And let me explain why that is y2 minus y1, because this is the length. And so from here, all over here, we're just looking at this. So to get to here, that's y2, and I will subtract my y1. So that's the length of this piece. So therefore, this piece is going to look at the x-coordinates. And your x-coordinate all the way up to here is x2. And that you will subtract that with x1. So the length of this is x2 minus x1. So let us assemble this now. So it's now going to look like my A squared will be this. So that's going to be y2 minus y1 squared. I just copied this out. Copy the plus, and then my B is going to be this, which is x2 minus x1 squared, because it says square there, and that is equal to my D, which is actually equal to my C. Now, this is partly not what you're going to see on the distance formula, because the distance formula says this. So distance is equal to the square root of x sub 2, well, there's a parenthesis, minus x sub 1 squared plus y sub 2 minus y sub 1 squared. And let me explain real quick. Well, first of all, that's an equal sign, so I can just interchange them and flip them. And this two are actually commutative because addition is commutative, so I can interchange them and write this in the front and write this here at the back. Now, really, the distance formula that you will see on your formula chart is going to be this. Okay, so now here you will have an example. Let's have an example. So let's say that these are the points that we need to find the distance of, and that'd be 3, and this would be 6. So the coordinates of these points are 2, 3, and this is 6, 6. Okay. So let's go ahead and apply the formula. So it's going to be, if I'm calling this my P1, I'm calling this my P2, then therefore this is my X2, that would be my Y2. This is going to be my X1, and that's going to be my Y1. And all I will do is I'm going to follow this formula. So the distance between these 2 points would be X of 2, which is this 6, and it says minus. I'm just going to copy that down. X of 1 says 2. I'm just going to copy that down, and then copy down the squared, copy down the plus. Those will not change, and then put the parentheses again. My Y2 again is a 6, and then my Y1 is a 3. So copy down the minus sign, and then that's a 3. And then copy the squared because that is part of the formula. So the distance is equal to square root of, this is going to be a 4 squared plus this is going to be a 3 squared, and that's going to be D equals square root of 16 plus 9, which is D is equal to square root of 25, which you all know is a 5. And what that means is, if I get my grid, and if I get a grid and I kind of measure it, it will show you that it is 5 because of 1, 2, 3, 4, 5 spaces right there. Okay, so example number 3. What if you have these points? I'm going to call this my P1, therefore this is my X1, Y1, and this is my P2, which is my X2, Y2. Now, just to emphasize again, somebody might get this as their P, as his or her P1, and this as the P2. Either way, your distance should be the same. For as long as you're consistent. If this is your P1, then this becomes your X1, Y1. And if this is your P2, then this becomes your X2, Y2. So now that I'm choosing this as my P1, let us begin. So the distance is equal to, so once again, practice putting the formula so that in the process you'd be able to memorize it as well. So x of 2 minus x of 1 squared plus y sub 2 minus y sub 1 squared. So the distance is equal to, this would be my x of 2, so that's parentheses 1 minus negative 3 squared plus, copy the plus, the squared copy as well. So once again, let me show this again. So my x2 is 1. There's a minus, so you put the minus. My x1 is negative 3, so I'm putting a negative 3 there. Squared plus y2 is 1. Minus is in the formula. y1 is a 6, so that'd be squared. Distance is equal to, we all know that double negative becomes positive, right? So 1 plus 3 squared plus, this is a negative 5 squared. And let's keep on going. So D is equal to square root of, that is a 4 squared plus negative 5 times negative 5 is positive 25. No more squared because you already did that. Here I need to keep on going. So that becomes 16 plus 25, which my distance is going to become a 40, square root of 41. and that cannot be simplified anymore. That is it. That is prime. So the distance is square root of 41.